Okay. So Mingxi, have you resolved that question 7, example 7? I take this part. Greta, have you done your work or not? Wait. Yeah, cannot hear Greta.
Oh, sorry.
What happened? Can.
Oh, I feel like my answer is wrong.
No, Bernice come in. Okay.
Oh, sorry. Why am so early?
I don't know. They're all early. Ayo, I see on 9, then I come in now.
I'm not late. I'm 5 minutes early.
Yeah, 5 minutes early. Okay. I just write the answer down. I don't know where's the answer. Wait. Let me see. Okay. 6 and 7. So I just write the answer. If we got any big problem. Okay. Part 1. This is
Sorry.
okay. If you are those type who are obsessed with exact answer, then you have the exact answer. If not, 3SF will do because it's not easy to get the exact answer. Yeah. Part 2. Wow, this one. Okay, so this is the questions. Example 6, example 7. Okay, example 7, in terms of P, you have to write it in the simplest form. Simplest form means no decimal in your fraction. Fraction is fraction, decimal is decimal. So try not to mix them up together. So this is your A. Then your B, your P is 79. Then your C.
I didn't get part B.
Yeah, I think Bing C also didn't get. She sent me solutions. Only she sent.
No, I got.
Oh, sorry.
I got a number above 100, which is very weird.
Cannot be above 100. Yeah, because
I got like 159.119. Then I was like, if it's 100 minus P, then cannot be.
Cannot. Yeah, probably you misread the question. I think.
Okay.
Probably. This part first. This is a nice number. Yeah. So you try to copy the answer down. Okay. Then I will try to move the answer. I see whether I can move or not. I don't know. Why I cannot move all the time? Okay. Okay. Can y'all got the answer?
I didn't get.
I didn't get CII.
You can go through 6.
I didn't get B.
Okay.
I also didn't get example 6 part 2.
Yeah, I didn't get 6 part 2 also. Then I didn't get 7C part 1.
Okay. Basically, it's like you have to go through a bit. Yeah. So 7A, all of you got it, right? Some form or another. Okay. Yeah. So Ken, we'll go through those answer question parts. Please copy down. Copy down as reference. Okay. Later. So we look at this quickly this question. So how far so far your lesson, how is it? School lesson, okay? Is it more relaxing than going to school?
You get to wake up later.
Kai Xing also, right? Get to wake up later.
Yeah, we just need to report at 8 every day for temperature taking online. That's it.
Oh, then you need to have live lesson.
Like the live lessons, like most of it they push to afternoon for some subject.
Oh, why?
Yeah, I don't know.
Oh, you know why or not? Because people find that all the schools starting at the same time very taxing on the laptops. You know, when the government announces the schools going to go online, then the computer shops become overwhelmed with all the people asking for laptops because they don't have enough laptops at home. Yeah, okay. So probably some schools they staggered. I think they put it to afternoon. Yeah, something like that. Oh, Bernice, your side okay?
Yeah.
Okay. We look at example 6. Part 2. Part 2. Part 1 okay, right? So I go to part 2. Okay. They say exactly 1 power. This example 6 is a very P&C question. It's a probability part involving P&C. So exactly 1 power. How do we get exactly 1 power? Then you have to split your 26 into 21 and 5. Yeah, you have to group in that way.
Oh, grouping.
I mean, you have to split it into these 2 groups. Because besides the vowel will be all consonants. It's either one of them. Therefore, we do something like this. Probability equal to 21 to the power 3. No. Wait, sorry. The power 2. 2 consonants, 1 vowel. You know why? Because you can repeat also. You can repeat the consonant. No need to 21 choose 2. You can repeat the same B and B, that type of thing. Yeah, I don't know whether you have that part. And then the numbers part, 2 odd. If you look at the 1 and 9, right? 1 to 9. And 1 to 9, you can actually have 2 groups of odd and even numbers. 3, 5, 6, 5, 6. So 5 odd, 4 even. Okay, so if you have that case, right? So your numbers will be 5 odd, 4 even. Then if that's the case, then you want exactly 2 odd digits. Then you have 5 square, 4 square, altogether 4 digits. Okay, beside that, what else? There's something else. Arrangement. Arrangements. You need the arrangements because when you choose the passwords, the alphabet will come one after another. You can't possibly have them at the same time all coming out together. Okay, so you have the arrangement. Then same for the, okay, I will, if you want, okay, never mind. Then same for the digits. You also have arrangement. Divided by
2 factorial, 2 factorial.
Is it okay? I understand this part? Can
Understand.
Can Then this will be over 26 power 3 and 9 power 4.
Why you must divide?
It's a
Is
probability.
that all?
Yeah.
Is that all?
Yeah.
Wait, the answer is what again?
0.138. Decimal will be
Because I
0.138.
had a lot of cases.
How come? How come you split into many cases?
Yeah. I don't know why. Oh, I see there's no need. Because I thought that you have to account for if they're the same even number or they're different even number.
Oh.
But I think I made a mistake. So I was calculating.
I think you're trying to split too many
Because
cases.
it's divisible. Yeah, but it's just okay.
When they didn't mention much, right? Then we'll try not to split too many cases. Then we try to make things simpler. Yeah, if you can okay. As I said, if you are obsessed with fraction, this will be the fraction. Yeah, I think I don't know you can get this fraction or not. I type it into the computer lah, so it shows me this fraction. Yeah. Okay, so can so far. Yeah. If you make a mistake, right, you have to really go and reflect through, right? For example, what happened? Did you miss out on the order? A lot of people miss out on the order. For example, it's a very common question. So, did you miss out on that? Okay, or your grouping not right? That kind of thing. 21, or you use 25 or what? I don't know. Yeah. So be careful. Okay. Yeah. So this part number 6 number 7. We go to question 7. That's number 7. Okay. Any questions so far? Two more probability question. Do you have questions from your school to do? Have enough questions? Slowly I will still give you questions to do lah. Okay. Yeah. But you must first make sure that you constantly do all these probability P and C questions. I feel like every week you should take 1 and 2. Okay? Then you have your mind tune into the type of questioning. Okay. Question 7 B. B. Okay, I'm quite happy that all of you can get A. Yeah, and this example 7 is an example of a true probability question, not P and C type, right? You can feel for it, it's not P and C type. And so this sort of question is good to draw a tree. Draw a tree is good. But you must assess the situation. Are you drawing a lot of branches? If a lot of branches, then no good. So here is not too bad. So you have this A and B supplier. Then you have P over 100. Then this is 1 minus P over 100. Right? Then for a supplier A, you have 40, non-40. I use as abbreviation 40F, non-40, and F. 0.03, 0.97. Then for the B, the 40 is 0.08, 0.92 for non-40. So every branch total must add up 1. That is your tree. Yeah, so the tree is good to draw because it's only 2 layers, 2 branches branching out. Yeah, so we use that to answer the question. So the B, $40. Okay, when it's 40, this means is A and F, the first branch, or B and F, from supplier B being 40. Okay, so if you have this as your equation, right, you shouldn't be wrong in finding your P. That means I suspect your equation may be wrong. I don't know.
Is the equation like 0.0405 equals to 0.03p?
Correct. Over 100. Can?
Oh, it's over 100.
I mean, yeah, it's this branch. I highlight this branch. This branch, the top branch. So
Oh, because I just put like p and 100 minus p.
You have to use back the percentage. If not, your answer may be distorted. Maybe.
Oh,
no?
okay. Then like, is it like 1 minus p over 100 times 0.08?
Yeah, lor. Yeah. Correct. Then you shouldn't
Oh.
get it wrong already. So you have 1 minus p over 100.
I think I never divide by 100 throughout.
Cannot, because your p has a different meaning if you don't do that. Yeah. So
Okay.
this one, like this. Can you all can see the branches with this branch. Yeah. So I feel that you shouldn't get this wrong if you draw a tree. So remember when to draw a tree is when you have a true probability question where you see the type of stages. You see like stage 1, stage 2. Okay, then you draw a tree. Or like 1 day, 2nd day, 1st day, 2nd day, that type of thing. With this sort of so-called I call it phases lah. Okay, yeah, you can feel it. Today, tomorrow, now and later. Supplier A producing 40 or non-40. So you have all these phases or stages. Then the tree will be coming in. But if you have a question where today, tomorrow, and the 3rd day, then you must be very careful. If you have 3 or more branches, usually very difficult to draw the tree. Then maybe it's not the way to do it. Yeah, so just be careful of it. Okay, then with the tree, right, how do we answer part C? Part C, all of you, part 1 or part 2 got some problem. Is it because you cannot manage the 2 chips? That type of thing. Okay, so I just explain here. Can I will erase this part now? Yeah, so it's just working to find the P. Okay, for part C, 2 chips are selected. Exactly one is 40. Okay, exactly one is 40. So in this case, I would say that how to do? Do you want to micro manage from supplier A, supplier B? No, no need, we just use this number. This is for 40. Then if you minus off, you'll be not 40 anymore. So this will give you exactly 140, one not 40. And when you have this sort of question, right, you always have to think about, do I need arrangement? Do I need ordering? You need. Why? Why you need? Yeah, because when you have 2 chips, then there will be always the 1 first, 1 second, right? So 1 first, 1 second. So you have 2 cases, which are exactly the same probability. You get me? Can? So this will be the answer. A lot of people should be able to get this part. Then sometimes miss out these 2. I don't know. Or you all miss completely. Or you go and micro manage. That means you start off from scratch. Supplier A 40, supplier B 40. If you do that, it's very, very difficult.
Start off from scratch.
Yeah, be careful of this sort of question. Okay. You see this statement. When they say the probability that a randomly chosen chip is 40, then they don't care is it from A or B. They already sort of like they care that it's not they don't care. They already take into consideration A and B already. So they produce an overall 0.0405. So this number will become just a general probability for a chip to be 40. You get me? So don't need to go into the micro managing part. Oh, yeah. Bernice, you get this part also? Can
Yeah.
Yeah. Then part 2. Both were bought from A, given that exactly one is 40. This one has some micro management because they specifically tell you one is from A. So in this case, no choice. We now have to break into the detail. Okay, how to do it? It's a conditional, right? because it's given. So you'll say probability both A, write in short lah, okay, phrases. Exactly 140. So your conditional will give you both A and exactly 140 over probability exactly 140. Okay, then if you go and look at the phrasing, you find that exactly 140 is done in part 1. You use your part 1 answer directly put into denominator. The only part you need to worry about is this. Yeah, so to do it, you have to go and micromanage. So in this case, you have probability. How to find it? Both A and exactly 140. So you have I write in this symbol, you see whether you understand. A intercept F times probability A intercept NF from the 3 just now, 40 and not 40, exactly 1.
Oh.
Okay, then
Wait, but if the situation.
need to order. Right? Get it? So something like this. If you have the 3 just now, it will be easy to see. It's from the first and second branches of it. So A intercept. Yes, Bernice.
Wait, but then right,
Yeah.
like they say it's given instead that the probability that random chosen is 40 is 0.045. Does it change it? Oh, okay, so
It's different because
stupid.
that one is in
Yeah,
general
yeah.
can be from the B as
It's
well.
following P equals 39. Okay. Get it. Thanks.
Thanks. Okay, the rest can get it. Can get the idea. I just write down this step. So A to B F A intercept F is how much? Here. Okay, then A again. Intercept not F. Okay, the P you have to submit yourself. Nah, then you can get the answer. This one is if your P is wrong, then of course everything wrong behind. Can so this sort of question very dangerous because once you have your P value wrong, you'll find that even though they would very much want to give you error carry forward, I tell you in actual marking internet exam, they don't have time. They will not give you a lot of error carry forward. They will still give you some mark, but it won't be like, you'll find that it will be wasted. Everything will be 1 mark gone at least. Okay, yeah. For Cambridge, they will give you 2 marks even though your answer is wrong. Yeah. Okay, so far okay, all of you practice. So I want you all to try some questions, then we discuss together. Okay, then I open up this and you try. This one. Okay, question 1. Try this question and see whether you see, is it a true probability question or is it a P and C type of question? There are basically these 2 types, okay, to solve. Try your best. No answer given so that you can really try out and be careful. And see, you need me to make bigger like that. Then after that, I make it smaller. The table very nice. I like the table.
The what?
The table. I like
Do you
like
make
the.
it?
I
Do you make the table?
No, I couldn't. It's so as
Oh.
I don't know. I make it partially. Yeah. I went to search in the internet for a table of this configuration. Yeah. So I have to type in Google search rectangular table with 10 seats. Then they show me all sorts of pattern. Then yeah. Then I try to get one. Have you done something similar? I'm quite sure you have seen something similar. If you have seen something similar, that means it's good for you. Because at least you know, oh, I've done something like that. What is Grander doing? What are you looking? Cannot.
Yours.
Huh? What? Kai
Never
Xing?
mind.
Okay. Kai Xing, are you doing?
I'm trying.
Are you doing the question?
Yeah, I'm trying.
What? You're fine. Are you doing the question?
I'm trying the question.
Okay. So if it's a P and C type of question, then you have to set your mind into thinking using P and C method to do it. Yeah. Okay. Let's talk about part one. Part one. You're done part one already. Part one. You see. Let's have something like this to try. Okay. I hand out something to you to write the answer down for part one only. I mean, we just play around with things if not very boring. Okay. This is a small board. Okay. You can type your answer in on the small board.
Oh wait, there are only 2 people.
Yeah. It doesn't matter. Does it matter? Whether 2 people or not doesn't matter.
Wait, no, I think it matters.
Okay. Yeah. Can you probability don't go and count the number of ways. So your probability is between 0 and 9 and 0 and 1. Sorry, 0 and 1.
sorry.
Yes,
Wait. How do I press wrongly.
it's okay.
Nothing,
It's okay.
Ignore.
It's okay.
How to submit?
No need. Just write inside can already.
Okay.
Just type lah, type. Don't worry, I just want you all to type something. If you get the answer, just type it inside. Yeah. Then no need to write your name and so on. Just type the answer. Then I will know who is answering. Kai Xing and Granda. Oh,
I think my answer wrong. But it's too small.
yeah, too small. Too small. Your one is too
Right.
small. Yeah, too small.
Cannot be, right?
Cannot.
But I cannot think of any other like.
That's why you see, you must learn how to think in the correct way. Okay, Kai Xing eh?
My answer is very small though.
Okay. For example, you just type something. It's between you and
I
me
feel like
only.
it's wrong. But,
Yeah, too small. Too small.
Yeah.
Okay.
Mr. Lau, is my one still too small?
Yes. Too small. Too small. Only two of you got it. So Mingxi and Bernice got it.
Sorry.
What? Okay, I collect the board.
I didn't expect to be correct, honestly. I just anyhow like.
No,
Because I realized it was wrong at first.
I'm giving you this writing board, right, is to just check your answer lah. Because sometimes you all don't answer, then I also don't know whether you're right or wrong. Okay, then or some of you just go along the flow lah. So some talking, then you just okay can. Yeah. So yeah, I collect I make it a stop so you cannot write anything already. Okay, so I collect back. Yeah. So this is the feature of the red board lah. Okay, then yeah, don't worry, nothing sensitive in it also, whatever you write there. Okay, then okay, now coming back to discuss this answer, part one. It's a probability, so you still need to have numerator and denominator. Okay, let's talk about the denominator first. How many ways, because we are using P and C method, so how many ways in total possible to seed the couple?
10 factorial.
One couple only, how come so many? Yeah, that's the thing, you see. A couple.
Wait, but I thought there's dummies.
Okay, if you
But
have
all the
dummies,
dummies are the same.
if you have the dummies, you may think of this. Get me? Because the dummies are the same. Yeah. Okay, for example. So you get it? You can think in this idea. What other ways you can think of? You can think of this way also.
MP2.
Yeah, or 10p2 is the same as
Yeah,
10c2 times 2 factorial.
But that's what I put as my numerator though.
Oh, this is not. This is the denominator, because this is the total number of ways.
Okay.
Total possible. Your sample space. Okay. Yeah. I tell you you all must take very seriously this topic and the P&C, because these two topics are sort of like paving way for the topics that you are going to study or you are studying. You get me? Because you have probability now and then in each of these topics that follows. Okay. Then how about the top? I want the couple to sit directly opposite each other. So directly opposite each other is, I can think of
5 choices.
5 choices? No, 10 choices.
10. Oh, right.
Then
Because
if
it's
I
times 2.
5, I can get a 6, right? So so this means that I have 10 choices. Yeah, and then I times 2 factorial. You get me? Yeah, every
Wait, but why?
Mm.
Why 10 choices then times 2 factorial?
Because
Isn't it 5 times 2 factorial?
5 times 2, why? You explain.
Cause like each seat is like
very
is
good.
like there's 5 choices for 1 and 9, 2 and 8, 3 and 7, 4 and 6, and 5 and 10. Then within those you can arrange the couple
So actually
like
10
times.
or 5 times 10 also can. Correct. You're right.
Huh?
You're right. That means it's either 10.
No, but or 5 times 2 factorial, right?
Yeah, not 10. Yeah. It depends on what you're
Mr.
thinking.
Lau.
Okay.
Yeah, okay.
10 is because you have 10 seats. Once you choose the, let's say the number 4, then the other couple will have only one choice to sit. Can?
Oh, understand. Yeah.
Can, So this answer will give you 1/9. Put in fraction if possible, because fraction is neater than the decimal. Decimal is recurring. Okay, if you want to put, you put the recurring decimal dot symbol. Don't put 0.111. Can? Because it's not if we can get exact, we will get exact. Okay, part 2. It's not seated next to each other on the same side of the table. Yeah. If you have the answer, you can submit into the whiteboard. Do you all have a pen or not to write on the, not this pen, those stylus, I mean stylus,
Yeah.
computer pen,
Yeah.
those iPad or don't know what pad thing. Kai Xing have,
Yeah, I have.
Ming Si have, Kai Xing doesn't have. Next time center will give you one. Yeah. Okay, now text drawing board. Okay, drawing board. You try, okay? Try and see whether you can do that. You can use your pen to write. It's quite fun. Or you
For part 2 is it?
1 part 2. 1 part 2.
Part 2.
Mr. Lau, how to erase?
You cannot erase, There's a
Yeah.
dustbin. There's a bin symbol.
But the bin doesn't work.
You click on the bin, then you click on the
Click
writing.
already.
Oh, cannot, Haha.
Yeah. Mr. Lau!
What? Can work.
Cannot. I cannot.
You click on you write something, then you click on the bin,
Yeah.
then you make sure you click on the bin properly, then it will show you, oh no, not the bin button, the crosshair button, the one with a
The
cross.
what?
This button, the arrow button,
I don't have.
this button
Oh, yeah,
with the
why?
arrow key.
Yeah, why?
You click on it,
Oh, okay, did it already.
you click on the drawing, then you
Yes,
click bin.
got it.
Sorry,
Yes.
that's a technical thing, yeah. Okay, for Kai Xing, you can use the mouse to write. If you, I don't know see whether you can write with
Mouse?
mouse. Yeah.
No, we are scribbling.
You can reach the mouse.
Wait, Mr. Lau, is there a computer app for this?
For what?
For this app?
If
Computer?
it's computer, we can just use. Yeah, is there like class team but like computer app, like computer program?
For writing,
You know, like yeah, no, like for this thing.
This class in thing,
Class in, yeah.
This class in is a app lor. You can put in.
Does it have a MacBook version?
Is there a max number of students?
I think max I don't know, but I think every student they put in here, right, they have to pay. That's what I know. But I don't know how much.
Oh, but
They
it's
pay
pretty
for-
good.
Your school using Zoom, right? Or
Yeah, but
Google Meet.
Zoom not very.
Oh, my school not using Zoom, using Microsoft
They cannot
Teams.
use Zoom already because there was like people who hacked.
Yeah.
Zoom.
Oh, you can lock the room. You lock the room, then can. It's okay.
Oh yeah.
But they don't know how to.
Oh, they must learn how to lock the room so that when you enter a room, you lock it, then nobody can enter. It's a physical room like that. Yeah. So as long as they can lock it, then okay.
Yeah, if not, anyone can come in.
I don't know. Or you can put a password. I think they never put password. That's why people can go in also. I don't know lah. I don't know. Yeah. Then yes.
Nothing.
Wow, this grander, what are you writing? Okay.
Very cool eh.
It's the same. I think if the school has any like vandalism, must be you. Then on the drawing board you'll draw this thing. Okay. Means you try to put in the fraction form lah. Decimal is not very good in general lah, because your fraction is recurring. Then wow, Kai-Xing very good. Kai-Xing can type.
Wait.
Can type. Good.
Okay.
Okay, I can also mark on your work. You see, I do something to Bernice's work.
Wrong.
It's correct.
Oh! Is it?
Yeah. I think you need to type in complete sentence one. Just write the answer.
I'm trying to think.
Okay. Mingxi, please reduce to simplest fraction form. You should know, fraction always simplest. There's a simplest form. Then grander, finally erased. Correct. Oh, if you want to erase, right, Mingxi, you click on this button. I think it's the number 1 button. First button on the left. Then you click on it, you click on your writing, you click the bin button. Then you will erase. You can try. Yeah. It depends on how many strokes you are writing. Yeah, something like that. So I think I don't know, you can put a square rectangular box there. You can you can hold on to it, then drag the surface, then you can use. So correct, then now it's grander. Grander, you can draw rectangle.
Wow. Yeah, there's a function.
Wow.
Huh?
You can draw rectangle.
You press the
you change color.
Yeah. And you can draw circle and rectangle. Perfect circle, perfect rectangle.
Wow.
Ooh.
But I need perfect answer. Grander.
Wait, I got this.
This is not so tough.
Is it eraser?
Wait, huh?
Is that eraser?
Yeah, you have to press the weird thing that Mr. Lau drew. Then you press the trash bin.
So Mr. Lau, you only want the final answer, is it?
Yeah.
What's the trash? Oh. What's the trash one?
You press this button, Wow, okay, you press this button, then you press on your drawing, then you press a bin, then you erase it. For example, is it Mingxi is drawing a lot of circles? Okay, Kai-Xing, I see your answer. So
wait, it's wrong.
Why? How you know?
Cause I forgot something.
Okay.
But I think it's still wrong.
Okay, I collect back the board. I collect back the board then.
Wait, I'm not done.
No, I collect already. Okay, then
okay.
you see you see grander. Can you all see grander's work?
Oh my god.
Wow.
Very
but very good, no? Wow, this part looks good. Wow. Fantastic. Okay. Then you look at whose work. Mingxi can look or not? Can see Oh, erase already. Wow, smart. She just now drew a lot of stuff. Then this is Bernice one.
Sorry.
Okay? Yeah. Can. Sorry, Okay, I close it. Yeah, the answer is 215. 2 over 15. Yeah, so y'all got the idea what to do. Okay, so Bernice explain Bernice
Yeah.
explain
Huh?
Bernice.
What? Oh, I explain.
Yeah,
Uh,
it's not seated next to each other.
so because there's two couples, then they can have. There is 4 spaces, so I don't know if it's correct the working because I just counted, but I think it's 4 choose 2 over 2 factorial. Is it? You get 3, which is the number of ways the couple can sit. But basically you can use I power also. Over 2 factorial times 2 factorial because the couples will swap around themselves, and times 2 because there's 2 rows, so it can happen in both rows. Yeah.
Oh, so this is
And
the
then, yeah, I think that one don't have factorial, but I don't know because like the same thing can happen in the other row at the other side because there's 2 rows of 4, right?
mm-hmm.
Yeah, so it's just times 2, then over the total, which is 10 choose 2 times 2 factorial, then you get 2 over 15.
Oh, okay.
How come it's 4 choose 2 over 2 factorial?
Oh, that one I don't know. Like because
then you write one
it is 2. Okay, but how I counted is because 4 spaces and 2 couple, right? So there's 3 ways to sit them if they're not together. But I didn't know how to explain that. I didn't know how to explain it. Yeah. Like, I don't
Wait,
know
so
how
it's
to...
like out of the 4 seats you choose 2, right? Because the couple can only sit in 2 seats, right?
Yeah, I guess.
Then how come you divide over 2 factorial?
But I don't know because I just counted 3, then I don't know how to make 3.
Oh, this one is a bit
So I
dodgy.
think that one is wrong.
A bit dodgy.
That is dodgy. Yeah.
Yeah.
Because I just put 3 when working, but I make it sound legit.
3 will be even better.
Is there a probability way to calculate it?
No. I
mean, technically it's only that, but
I think no.
then it's just 3 lor.
Because this is
Okay, then it's just 3.
3, yeah.
You hit X and then put 3.
Don't try to make up the number. I think it's yeah, because it's your honest way to do it. So like if you get 3, it's because it's you just directly do it like 1 to 3, 2 to 4, then what 1 to 4.
1 to 4.
Yeah, so there are 3 types of pairing you can pair, right?
So you just count, is it?
Yeah, just count.
Yeah.
Then how? So we just ignore the 4 choose 2 over 2 factorial?
Yeah, correct. So you have 3, then you times 2 factorial because of the man and woman. They can have 2 ways to sit in the pair of seats that you've chosen. Then this is the 2 rows, right? I think Mingxi, you did it a complementary way or direct way?
Direct way.
Direct way, direct way not too difficult because you can see how they sit. Not many seats there, so you can actually visualize them. Okay. P and C is very practical type of thinking processes. So as long as you have that very down to earth way of thinking of things, manage them properly, then you should be able to explain okay, how to get those numbers like that. So don't just put in any number you want. Yeah, if you are counting it directly, I tell you P and C, the most basic form is direct counting, direct listing out. Yeah, it's because people find if you directly listing out things, right, it's very time consuming, so they come up with all sorts of different methods to do it. Yeah, but basically if you can count, you don't need any method. If you have a question, right, with 400 combinations and you can list them down and then you say it's 400, then your teacher will be giving you full mark. Your teacher has to
So for this one, do we need to list down?
No need I think it should be okay. You just explain. Okay, like all these things, right, you explain. Then you explain things like 3 pairs of seats to be non-adjacent in one row. You all write all these things or not when you do your P and C? do you write all these things? Try to write this type of little phrases. The more you write, the more you are getting used to it, and it will help in your explanation. Okay, then you will find that you can write any broken language, but still people can understand. Yeah, okay, instead of long sentences, you will be wasting a lot of time. So try to write short sentences. Okay, can Kai-Xing more confident, you can do it one. Okay, let's look at part 3. Part 3 is a given. So the word given is a mathematical term that tells us it's a conditional probability. So read the question and see whether you can do it. Read, yeah. Then we do it together, okay? We do it together here. I will abbreviate certain things like this. So it's seated next to each other. So I say it's adjacent. Okay, try to rephrase it. Adjacent given man on odd seat, something like that. So people will understand. Okay, you want to write the full sentence, it's up to you, but can cut it short will be okay. Then the top is this. Then over. Okay, what to do to the top? The couple must be adjacent, sit next to each other, as well as the man is on the odd seat, odd number seat. So here, of course, the focus will be on the man because the man is more the more conditional guy, right? With more condition there. So you have to look at the man. So the man can only sit here, 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 and here. But the man in the end cannot sit there because they cannot get side by side seats. Okay. So in this case, there are these few cases. If the man is seated at number 1, you'll find that number 1 and number 2, number 1 and number 3, there's a difference. Okay, why? Because if the man is seated at number 1 seat, the woman can only sit at number 2 seat. But if there's man on the 3rd seat, the woman can choose 2 seats to sit, either on his left or right. Get me? So if you do that, it will be direct counting. One way, 2 ways, 2 ways,
6 ways total.
Yeah.
1. Yeah, how do we write it?
I wrote like man 1, woman 2, then man 3, woman 2, then man 3, woman 4.
Oh, I say the first
Is it
number
bad?
is I would do it this way. I would say it's 2 times 1 plus 2 times 2. Then I will explain this like number 1 or 9, this number 3 or 7. Okay, this is wife, the woman, sorry, not woman, something like that. No need to explain very long sentences. The people who are marking your work, they also know this problem. They are math teacher, they know what they are looking at. Okay, so when you write something like that, then you just yeah, I mean that's your 6 ways. Then after that, then the bottom, if the man is on the odd seat,
then choose 5.
No, 5 choose 1.
Is it nice?
Oh, right.
5 choose 1 because the man must sit. Man must sit on the odd seat. Then the other one, how about the woman?
9 choose 1?
Yeah,
Is
because
it 9 choose 1?
correct, because the woman may not be adjacent to the man anymore. It's on the woman. So what is the answer in this case?
Half. You half?
Huh?
No. Yeah.
Same answer as the part 2. That means part 2 and part 3, they have the same chance of occurring.
Wait. No.
Yeah.
Wait. Yeah. Oh yeah. Correct.
Why?
Yeah.
What happened? Okay.
Nothing. I thought that, yeah.
Okay. When you do this sort of question, it's a P and C question, then you'll be focusing on looking at the numerator and denominator as a number of ways to get them. Okay, so you have to be very focused on what method you are using. Okay, the idea is P and C, so you focus on counting. Okay, when you count, be careful. Will it make a difference if there are 8 other people coming in? No difference, huh?
Yes.
No difference one.
Why?
Because as long as there's no condition to other people, they won't affect your arrangement. Okay?
The women be affected.
Huh?
Won't, like, if other people come in, then, like, won't the women be affected?
It's the same, right? You see, it's the same as this idea. You're now solving this problem. But are you going to care about people walking around and standing around the table?
Also, they haven't sit down yet.
No, what I mean is that when you do a problem, right, there are actually other things happen outside the problem. Okay, but it's because other things outside the problem, there are no condition to them, no restriction to them. Therefore, they won't affect your ratio of your probability.
Okay.
Yeah, the number of ways will be different, but the ratio would be the same. Something like that. Do you get this idea? Of yeah. Okay. But of course, if the people are seated right, then it will be this. If there are 8 people, there will be 8 factorial. Understand this? At the top and bottom. Because they have no other restrictions, so they can easily sit on the remaining 8 seats.
Okay.
Yeah,
but like, you don't write it down cause like they cancel each other out.
Correct. So probability has this little thing about it's different from P and C. A little bit different because probability is a ratio. So it will sort of like cancel all these things along the way. Yeah. Okay. Let's look at question 2. Question 2. It's a very poor thing. So grand not grander, but grand. Okay. I checked the grand's name. The grand is often attributed to a boy's name. Yeah, but still girl. I think some people still call grand as a girl or Glenn. Is it a girl?
No.
No, still okay. Yeah, you check internet. There's a small portion of people feel grand is a girl's name. Yeah, okay. Anyway, here. During this you all read circuit breaker period, each day grand is very pitiful. He will have dinner either in his bedroom or in the hall. Then he has dinner in his bedroom is this. He has noodles when he eats in his bedroom is this. And noodles when he eats in the hall is this. Okay, what type of question is this? Is it P and C question? Yeah. And does it have a sequence? Stages?
Yes.
Yeah, so probably a 3 will be good. Yeah, so you feel it it's a true probability question, then it has come with stages or sequences. So it will be good to have a 3 lah. Okay, suggestion to have a 3. I mean this is how I'm trying to see like how do we manage questions better? Yeah, so you have this part, so you have this one. Bedroom and hall. Can use abbreviation. Bedroom and hall. So bedroom is 75.75. He likes, you also like, right, to eat in the bedroom. Okay, then got cockroaches.
Yes.
Got cockroaches or not? My house a lot of cockroaches. Not a lot. Always see cockroaches. I don't know why. Yeah. We see out the bin also got cockroaches. Yeah. And one day my daughter's pencil case also got cockroach. So she opens and she saw. And then I always the one catching all the cockroaches because no one in the room, no one in the house there to catch cockroaches except me. Okay, this is noodles. This is others. We don't know what he eats lah. Okay, others. Okay, noodles. Others. If the tree is not difficult to draw, it will be good to draw the tree. As I said before. Then this is 0.8, 0.2. Yeah, so this is your tree. Part 1. Find the probability on the randomly chosen day he has noodles for dinner. So how to calculate? You all know how to calculate? This is very similar to just now the example 7, I think.
Is it 0.75 times 0.6 plus 0.25 times 0.8?
Wow. Yes, correct.
Okay.
Despite you saying so fast, I can catch. Correct. Correct. Y'all got it? Try. Okay, try. So this will become this. I hope you all don't like resistant to drawing trees. This is a very important process, okay, of the visualization. Up to you, fraction or decimal. Okay. Remember this sort of question in example 7, you have problem? The 1, 2 chips. Here is 3 days.
Yeah.
3 random days. Find the probability he has noodles for dinner on exactly 1 day. Let's look at this part. Then yeah. You all finished discrete random variable already? Hello?
More or less, I think.
Bernice, Grander, okay. Finish, right? Mingxi, no?
Halfway.
Halfway. Learning what? Expectation?
Don't
know.
The binomial part.
Oh, okay. Kai-Xing? Oh, Kai-Xing finish until don't know which one already, right? Yeah, very far away.
Yeah.
Okay. Right. So part 2. After part 2, I will end here. I won't do anymore because you will be doing on your own. Can? I will send this copy to your WhatsApp. Then you do. Yes, Grander? Always you answering.
Is it 0.65 times 1 minus 0.65 times 1 minus 0.65 times 3 factorial?
No.
Over 2 factorial.
Wow. Promising. I just missed out the first part. Okay.
Wait, what? What did I miss?
I missed out your... Because I heard your 3 factorial, then my mind was focusing on 3 factorial is wrong. So I forgot what you said. You said 0.65?
Times 1 minus 0.65.
Yeah. So
times 1 minus 0.65. Yeah, then times 3 factorial over 2 factorial.
Yeah, very good.
Okay,
correct.
Thank you.
Okay, y'all get it? not micromanage. Okay, you look at the broad sense, use the part 1 probability to handle the problem. Okay, why is that a 3 factorial over 2 factorial? It's because exactly 1 day, so it's 2 other days are repeated, okay, of the same outcome.
Mr. Lau,
Yes.
if I do it by like cases, right? Like first day noodles, then others, then plus second day noodles.
Also can.
Is it?
Also can, but not preferred, because if you have 10 days, then you have to have a problem. Then you have to list down many of these. Okay, but this is if you learn your binomial. This is a binomial. It's a binomial problem because it's either each day is either you take noodles or not take noodles. So there are 2 outcomes, and every day is independent, that type of thing. If you learn your binomial topic, can. Yeah.
How you know if the probability is constant?
We don't know. We have to assume. If you
Okay.
if not, then this problem also cannot do. You get me?
Okay.
Yeah, you have to assume they are independent. Okay, if not, then Grant will be like very tired, then don't want to eat noodles, then whine over it, then I don't know lah. Okay, yeah, or he loves the noodles so much, then the other day he will have increased interest in taking noodles. Yeah, or the mom doesn't want to cook noodles, so you don't know. Yeah, so we assume constant. Okay, constant behavior throughout. Can. So for the remaining questions, like question 2 and this 2 part 3 and 2 part 3 not easy. I want you all to like think about it. That's why I'm not doing it here because it's going to take up a bit of time to think and so on. Yeah, so and question 3, especially this sort of part 4 question where you have 3 intersections of things, those are like this. Yeah, this sort of question, then try them, very important. Okay, so it's a homework for you. All right, so I won't touch these probability questions really. Can? Yes, can. Yeah, so I send it in the WhatsApp, then you can go and check and do the question. Then now I want to talk about is the discrete random variable. I'm doing this sort of bits and pieces so that I just want to check your knowledge whether you have that. Okay, and then we just move on. Can? So I close this part. Yeah, you all can take a short break if you want, just running away from the screen break. Okay. Yeah.
Oh, still can bring. I need to put my charger.
Okay, I sent you in the WhatsApp just now the thing, so you can check and when you do, you just try out. Okay. So we push on yeah, later when Bernice come back. This first part is actually I sent it to you before already in the WhatsApp. Okay. Yeah, it's on the summary. I do a bit of the summary for each chapter as far as I can, especially the smaller topic, not too bad, can do summary quite easily. Okay, so discrete random variable is talking about random variables that can be counted. Okay, so these are some of the important facts I think you need to know. Actually, do you all go out or not during this period? Do you like leave your house at all? Huh? Have? Try to leave the house.
Not so far, not haven't.
I like to leave the house now because you find outside very quiet. Then you also can see whether the police will catch you or not. Yeah. So actually it's different, no? It's just like they talk about India, right? India, they have their cities are very populated with people. Then because of the lockdown, then the streets now become like filled with stray cats and dogs or everything. Then it's a rare moment. Yeah, that type of thing. Okay, so like Singapore also, if I go out, then I feel like, oh, there are really very few people around. Even going to the car park, normally there'll be a lot of cars. You have to wait for the car park lot. Then you find suddenly quite empty Yeah, so it's quite different experience. You can take picture and so on. Yeah, don't need to, and lie on the road and then take picture. No cars come to you. Yeah, okay. Okay, this one, random variable, no big introduction. So it's just a variable that has no predictable outcome. Okay, yeah, you cannot predict the outcome, but the outcomes are all there. Yeah, okay, and then this one is the discrete is can be counted. Okay, then probability distribution is always there for anything that has a change. That means as long as you toss a coin, the coin can be different outcomes, then people can talk about distribution. Okay, even you yourself is a distribution. Yeah, you can appear here in the room. There's a probability of you disappearing totally. Yeah, that type of thing. Okay, then all the probabilities in a distribution total all add up to 1, and it's all between 0 and 1. Okay, individual. So this one you know already. Then expected value in statistics is just the mean. So it's a fanciful name, expected value or expectation. Yeah, and then it has this symbol mu or ex. Okay, and there's a formula. This is a very important formula. Then all of you remember this formula? Sum of x times px. No, Glenda, you know or not? Then these are the important properties. Expectation of a constant is always a constant. The reason is because the constant has no change. So your mean is the same all the time. Hey, Bernice, you're copying that?
Just taking some stuff down.
Oh, not the math. Okay.
Yeah, not the whole thing. Yeah.
Then EGX is very important. Okay, EGX is to find the expectation of GX, which is GX times P x equal to X. So example here, no matter how complicated your function, the underlying probability always the same. Why? Just like you roll a die. The die has faces like 1, 3, 5, that type of thing. Okay. Then if you go and square the number on the die, the underlying probability still remain the same. The die won't change because you change the numbers on the faces. You get me? Yeah. So when you do a expectation of a function, the function number will multiply to the same underlying probability. Okay. Then after that, this is not too bad. I think a lot of people can accept it. E of ax plus or minus by is this. Yeah. I just go through the properties just to recap. Yeah. Variance is a measurement of the spread of some variable. Okay, the distribution, the spread. Then the symbol is very common, is sigma square, and this is your definition. But people don't use this definition. Very often this definition is not used because it's very hard to use. Okay, but this one is the more common one. Very practical, common. Okay. Variance of C is 0 because a constant has no variation. So you can explain that way. Then variance of fx is actually just using the definition here. Its definition. So E of whatever you have, square minus E of that thing whole thing square. Yeah, example is this example, variance x square is with e x square square minus ex square whole thing square. Then finally, this part is very important. Variance of as plus or minus by is a square variance x, always plus b square variance y. Okay, but provided x and y are independent. If the x and y are not independent, this result won't hold at all. Okay, so this result is only for independent. Yeah, so this one so this is the whole topic, the first part of discrete random variable. With this knowledge, you can solve all these questions in the discrete random variable section. So for example, let's have a bit of practice together. Okay, so for example, question 1, you have a discrete random variable x taking on the values 2, 3, 4, and 5 and no more with the probabilities as shown. So find k. For example, find k. Idea, how to find k? Don't get into the value, okay? I'm not going to talk about exactly what's the value. So the idea, how to find k.
Mr. Lau, can we make bigger?
Oh, really cannot. Wait. Can I erase this thing first? Can, sure. Okay.
Thanks.
Because if the screen is, if the thing is bigger, then I cannot write too much.
Oh, okay.
That is the thing about this board. Yeah.
Or why don't you remove the white spaces at the side?
Like that. I push it to the left. Can. Thanks. Yeah, I was trying to tell the admin to take away all these things. All this. Occupying the space. Yeah. Sorry, but it's their logo lah. Okay. They want that. Okay, find k. Can we go through quickly how to find k? What's the first thing you think of?
Probability is that the total equals to 1.
Yeah.
Then we can find k. Can? Idea only. Yeah, once you get the total probability equal to 1, the idea, then you can actually find k directly. So something like this. Something like that. I'm not working out now. Then you can find k that way. Okay, so this is how you find k. Get the big idea. I feel that if you don't have the big idea of doing problems, then you cannot do the problem at all, even if you know the fine details. Okay, part 2. E of modulus cosine x.
Multiply cosine x to 144k. Wait, cosine 2 times 144k, then cosine 3 times 136k.
Very good. You get the idea already. Okay, it's something like that. Cosine 2, but put the modulus in radian then multiply to 144k. The rest can follow or not?
Yeah.
Can follow then cosine is 36k. We still put the modulus. What's the reason? 2, 3, 4. Because cosine of 4, all these numbers may be negative. So we still put the modulus, even though it seems like no negative, right? But we don't know. The cosine may be negative. Okay, so this is part 2. Part 3, find the probability x1 plus x2 equal to 7. X1 and x2 are independent observations of the same x. Yeah.
3 and 4. x1 equals to 3, x2 equals to 4. Then x1 equals to 4, x2 equals to 3.
Very good. So
Is it?
Yes, correct. So 3, 4.
Oh, then 2, 5.
Like that. Yeah, so if you do that, then how do we find the probability of 3 and 4? First case, for example.
I don't know.
Huh?
I don't know.
No lah. It's the multiply with the associated probabilities lah. Understand? The rest? Kai-Xing? Ming-Qi? Second one is this. Because when you write 3 and 4, this means that x1 takes 3, x2 takes 4. So when you do that, this will constitute to an event, right? So this event, you have to multiply the two probabilities together to get the outcome of the probability. Okay, so when you do practices, this will be the way you do practices. You don't need to complete the question. You just need to know how to start. Then you can move on. Get someone who is more experienced, your teacher, your dad, me, your senior, okay, who must be someone better in the subject. Then they can judge for you whether your idea is correct. Then you can move on. Then you can do many questions. Okay? Yeah. All right. Let's look at number 2, part 2. I want to focus on 2, part 2. Okay, 2, part 2. Why I focus on 2, part 2? Because 2, part 1 is, to me, after I finish my question 1, I feel this sort of question, how to solve for A and B, let's say. Kai-Xing, you answer?
Did you just start in the x value with -3, -5
Very similar to just now the question 2, part 2, right? Question 1, part 2. Get me? You have that idea of putting in the numbers for -3, -1, -3, -1, 1, and 3. You just put in, then this part will give you something like this.
But you only have one equation for.
Yeah, correct. So you need to always bear in mind, I need to look out for 2 equations. Sorry, it's a sticky pen thing. Okay, something like this. There's no 2-way out. Last one is 0 lah, by the way. Yeah, then this whole thing equal to 3.2. Then you try to form one equation. Okay, then always remember, that is what Bernice just now talked about it. Total probability equal to 1. This knowledge must always be in your mind when you do a discrete random variable type of table problem. Okay, for a table, this is very important. Total probability, whether is it given or not, whether you need it or not, you must always have this in your mind. It is always equal to 1, and you may use it anytime. Okay, so from there you solve for the A and B. Get it? Yeah, we are not going to the detail, so let's look at part 2. How do we get part 2? No detail, just the idea. X bar is the average of 2 independent values of x. Find probability x bar is more than 0.
Is it like -3 plus -1/2, then you list, then you find whether it's more than 0?
Yeah, something like that. So actually this question is similar to 1, part 3. Why? Because x bar more than 0 means x1 plus x2 over 2 is more than 0, which means Yeah, so what is this trying to tell us is that we are still more familiar with like having two explicit observations visualized to us, and we can actually sort of like easier for us to think about what combinations to put in rather than the single x bar term. It becomes a bit obscure. Okay, so here
Mr.
yeah,
Lau,
correct.
then for -3 and 3, right, it's not considered more than 0, right?
No, not because it it's equal to 0, so cannot. Can so from here
Yeah.
from here it will depend on your own already, on your own journey, because it is your ability to sieve out all the possible cases. Can so it's not cannot be learned that way, in a way there's no proper way to do it. Okay, yeah,
Is there an order also?
yes, there must be order because x1 x2 still two different observations. Yeah, right.
Okay.
Can okay, I'm always afraid of the story problem. To me, I feel story problem is very dangerous. You know it, okay. You don't know it, it'll be a struggle because you need to get the story right, right? So let's look at number three. Number three. Okay, and for this part, right? You see whether you can get this question answered. But this question is very good. The question gives you a checkpoint. This is a checkpoint, a stop for you to check whether your idea is correct, right? If the question has no checkpoint, those type of questions are, in my opinion, very risky. If you do them, you may get completely wrong because your idea may be different. Yeah. Okay. To me, I feel that questions that are more difficult, they have checkpoints because if the idea is difficult to understand, people will give you some way to help you confirm certain thing. Yeah. Okay. So read the question on your own. Good to draw picture. Picture will be able to like visualize better in general. Yeah, don't be afraid to draw pictures. Picture will cut down a lot of the reading. Yeah. Then of course the die, what happened to the die? It shows one or two. Okay, something like that. Yeah. Are you able to work up? Okay, this will be my drawing. If I want to do the question, I will have some drawing. Maybe simpler than this. It's because I'm trying to show you what to do. But on your own, you probably will draw even simpler diagram. Yeah, just to capture some of these big stuff moments again in the question that they display. So yeah. Now is how do we get x equal to 0? You try and see whether you can get this number, probability x equal to 0, equal to this number. If you can get, that means, yeah, that is better than nothing. Yeah, better off. Seems like Mingxi got it, huh? Yeah, Mingxi not actioning. Bernice also, Bernice already finished, and she's looking at calendar.
No, I'm not. I'm not looking at you.
Bernice is looking at calendar because you see she's leaning close to the calendar side.
I'm looking at the question.
Okay. Try to get can get x equal to 0? Can? Kai-Xing can?
Long. I feel like there should be a shorter way.
Oh.
Like I'm doing each case individually.
For what? For x equal to 0
Yeah.
Oh, because you look at it 1 mark
I don't know why, like.
No, don't get deceived.
I don't know why.
Some of these should be cases lah. Should be cases, I feel.
6. Wait, how many? There's
Okay. We do
there's 6
together.
cases, right?
No. 2 cases. 1
2?
case, 2 case.
Oh.
First case, second case. Because they are the same one. They are going to have the same type of outcome. Yeah.
Okay.
But 1 mark is a bit low 1 mark a bit low. Yeah. Frankly speaking, the 1 mark gives us like oh, what happened? Is it really like 1 mark so short? No, it's actually some idea involved. So first case is 1 or 2, so it's 2/6. So when you write your probability, you must write in the raw form such that you can tell a story to the person why the numbers are like this. So 2/6 is better than 1/3. Okay, so 2/6. Then after that 2 from each 2 from N1. Okay, 2 from N1 is without replacement. How to do without replacement? Yeah, to do without replacement, right? It's the same as choosing together. So it's something like this. So it's 5 choose 2. Why 5? Because x equal to 0 means no red balls. That means the person must have chosen all black balls. So there are 2 black balls. If I want to make it explicit, it will be 3 choose 0 lah. Okay, for example. Yeah. So after that, what is the probability? It will be over.
2. Oh.
8 choose 2. Yeah, because it's a probability. Don't forget the denominator. Then plus the second case, because now it's case
Don't
2.
you have to times 2?
No need.
Oh, you don't have to times 2
because
okay, I understand.
We are just choosing. We are not even ordering the balls. Okay? Yeah. So the other one is 4 over 6. Either 3, 4, 5, or 6. Now is I don't want to be so explicit. So I will choose one from each n. So 5 choose 1 from n1. Then from n2 will be 4 choose 1. Then over 8 choose 2.
Mr. Lau,
Yeah.
what if, right, one urn is, let's say, 6, then the other urn is 8, right? Like, one is 6 balls and urn 2 is 8 balls. Then what will happen to the denominator for?
You just do according now. So the 8 is the total ball. So the total will change if your total change. So like if the first urn got 10 balls, then you have 10 choose 2. If got 10, it will be 10 choose 2. You get me?
Oh, as I'm saying for the second part.
Oh. Sorry. No. Haven't finished yet. Sorry, this is not correct. This is not correct. It should be 8 choose 1. 8 choose 1. Is it okay? That means we just look at one urn by one urn. You choose, you have a probability. So I can lump them together, but the total you must take care with each urn, coming from each urn. Can Yeah. So this one will give you the answer, supposingly. So here it will be like I don't know, you have to close your eyes, press your calculator, hopefully you get it, then you move on. If you don't get it, this is where people get into a big problem. Okay, normally when I see people doing question, right, they don't get this part. Once they don't get this part, the whole idea is gone. That means they are not so calm anymore. They find how come cannot get? Yeah, then in this sort of cases, it will jeopardize your next part. So be careful in the exam. Try to be very, very careful when you do that. Okay? Like me, you see, I so careless. Okay, how to find the distribution of x? What is the presentation like? Okay, can I erase this working, can? You all calculated in this way also?
For part, wait, no, it's very different. Not very different, but I use like probability.
You use what again?
Probability. Like it's basically the same thing, but I just didn't put like choose whatever.
You give like 5 over 8, is it? 5 over 8, 4 over 7.
Is that okay?
Yeah, sure, okay. Can.
Okay.
Can we look at the.
Wait, how do you do it with the 5 over 8 method?
Okay, I show it on top here. Oh, cannot. I show it below here. Here, can? Yeah. So you have this one. Then you still have your 2 over 6. Then for the probability, the first is black. So it's 5 over 8. Without replacement, 4 over 7. Finish. Then plus the second case, 4, 6.
Wait, why 4 over 7?
Because you choose.
There's no replacement.
From both urn 1. Yeah, so you have one total less. One less for the total. So 4, 6 here also the same. 5, 8. Then the second one is 4, 8. Remember to show your raw numbers. Okay, so that we understand the physical numbers coming from where. Can Bernice, you did it this way, right?
Yeah.
Can. Let's look at the distribution table. Okay. Can I erase this part and that my part also. Okay, how you all do it? Like for example, right? In your working, I would like to build the table first. So I will build the table. Sorry, not very straight. I build my table. Then I have to be very careful what type of outcomes I can get. So X is the number of red balls I get. So it will be either 0, 1, or 2. No more already. If I think very hard, yeah, no more already. But you must think very hard. Make sure you exhausted all the cases. If not, you get into big problem. Okay. Then here, I have one for free. It's given in the question. So if you can get it, it will be good. You just fill out this part here. Yeah. Now, how to calculate probability x equal to 1? So for all the other probabilities, I will fill out below. I will show working below. Then once I get the answer, I fill out the boxes in the table. Yeah. So x equal to 1 means what are the cases? Okay, let's try. See whether you okay. You're coming from different schools. I've seen very difficult questions even from like Yishun JC. Even though people find, oh yeah, Naples JC shouldn't be giving difficult questions. But it comes to statistics, actually all the schools are about the same. The type of questions they set. So try to do well in statistics. For if you are going to get A, right, for your final exam, your statistics is upon 60%, you should score near to 50%. So this is I write it down. Usually for a good student, okay, I normally see the student getting 50 out of 60 in their paper 2 for stats, around there. Yeah, yes.
25/84.
You get that? The rest?
Is it?
I don't know. I don't know.
Wait, this is for which one?
X equal to 1.
Yeah.
Oh no, one's different.
Yeah, mine is different also.
Oh.
I think
So,
mine's too simple.
okay. So, this is your first outcome. Then after that you
Times
have
5/8.
you use the probability method.
Yeah.
5/8.
Then times 3/7.
Some more.
Then plus 4/6.
For a second die,
Times 5/8.
second case.
Times 5/8.
No. Wait.
Sorry,
Where's the first
3/8.
number? Where's the first number for? The 4? Wait,
No,
wait,
it's 3/8 times 4/8.
Okay. 3/8. Okay, I annotate a bit of things. This will be a red. This is a black.
Oh, 3/14.
Huh?
3/14.
For which one?
The answer.
No. The working is this working? Yes.
Yeah.
Why is it 3/8 times 4/8?
Okay, I explain a bit. No, this is not the complete answer. But I just explain a bit on the second case. So 4/6 is for choosing a red right in the first urn. So this is the first urn. Then this
you
is
can
the
choose a
second
black
urn.
in the first. Black in the first urn and rate in the second urn, right?
Yeah, so there's a second
Oh,
case.
do you plus or plus?
It's a plus. So this one is black.
5/8 times 4/8.
Oh, you get it?
Wait, for the first one, right, you need to times 2.
Yeah. Do you know? Here you need to times 2. The reason is because there are different outcomes. The first and the second without replacement, there's a difference. Red first or the black first, there's a difference.
Oh,
Okay?
okay.
No.
Yeah, so if you do in this way, right, you should be getting the answer for this case.
What's the answer? Is it
I don't know, I didn't calculate out.
is
Sorry.
it 43 or
For 3/84.
Yeah. Wow, your press better.
I'm using the normal calculator,
Me too.
not the GC.
I'm using a normal
Oh.
also. But if I go for exam, I sure I think I don't know can get A or not. Yeah. Okay. Last one. S equal to 2. How you calculate S equal to 2?
1 minus the first 0 and 1.
I will say that this method is very risky. So if you can, try to calculate again. Why?
Okay.
Why? Very important.
In case your answer is wrong.
In case some parts you are wrong, you cannot detect anymore if you want minus. You get me? So if this is provided, right, under the situation, you have time. You have time to do it. Okay? Another situation is you really cannot. The case is impossible. It's very difficult to calculate. You find you 2 times calculate also calculate the different values. So maybe resort to 1 minus. Can? So if you can, it's always the last resort. You always try to calculate directly. No? Everyone get it? Okay. So this one I won't go through the detail lah. I think you know the mechanism already. So something like that. First one, 2, 6, then followed by rate, right? So it must be 3/8, 2/7. No need to times 2 because they are the same outcome, right? So the second case is 4, 6. Then after that, a rate from the first urn.
I thought you had to times 2.
No need.
Oh, you
Because,
don't need.
it's the same as 2 bread. Yeah, the two outcomes the same. So this one is the first urn. Then the second urn, 4/8 is still a rate. Okay. Then after that, do we need to reverse?
Yes. Oh, they don't.
Why? Because they are red, what? You can't distinguish, right? Which one you have chosen the red from, that type of thing. So
Okay.
yeah, so this is your S equal to 2. Then if you get the answer right, you can check plus together is equal to 1 total. Then this will be a better way to check all your working. Okay, so this is always we always want to hold on to this sort of calculation so that we don't like blindly doing the problem. Okay, you understand what I mean? Yeah, look at the question on expectation and variance. Okay, how to calculate the expectation and variance? Okay, let me calculate. You all know how to
Okay, it
calculate?
adds up to 1.
Sorry, add up to 1.
Mm.
You all know how to calculate the variance and so on? Can?
Variance is the x square minus the whole thing square.
Okay, So we use this formula to do lah. But I think you
Mm.
can do it lah. Okay, so we don't do it here. Is it okay?
How do you find expectation?
Just
Oh, you multiply in,
0
right?
times, yeah, this one, the basic one.
Okay. Yeah.
Can?
Okay.
And so on. And the last one. Can yeah. So this part here. Next question. Do you understand question 4, this idea? Okay, Amy and John, they play a game. Okay, using 2 dice. One is fair, the other one is biased. And the biased die has this distribution probability. So yeah, still have 1, 2, 3, 4, 5, 6 lah, but different probabilities. Okay, Amy is to throw the dice. John pays Amy $2 if the total score is 3 from the 2 dice, and pays Amy $1 if the total score is 4. However, if one of them shows a 1, one or both show a 1, then Amy pays John 50 cents. Both players receive nothing for other outcomes. So X is the amount Amy gains after one game. Yeah. So it's a story. Then how to show that probability x equal to 1 is 1 over 36. So again, this sort of thing, you need to draw a picture of what is going on. Okay, so in this way, Amy gains, right? So in this case, Amy gains a +2 if what happened? If total from the 2 dice is 3, then Amy +1 if total equal to 4. Then Amy negative, because she's not gaining, she's losing. She has to pay John 50 cents. So negative 0.50 if total equal to not total. If the die is 1 or if 1 or 1 1, something like that. Okay, so this is the story. Then otherwise will be 0 lah. Yeah, so main thing will be these 3 scenarios. So the question asking you x equal to 1 means, of course, means Amy gets $1 after one game. So if it's after one game, right, $1 getting $1, that means the total must be 4, right? If she's going to get $1. Then now, how to get the total to be 4? Amy throw 2 dice. This sort of story problem very common, just like number 3. So you have some form of situation, then it's either this or that type of thing. Then you need to be very careful about getting the probability. So it's still probability, right? Try and see whether you can get 1 over 36. Try to get like 1 attempt correct. Why? Because some questions they don't even have a checkpoint, so this information may be missing, right? No checkpoint means that everything must be 1 attempt correct. If not, then you're going to you won't get the answer. Yeah, so to get a total of 4, you need to be careful how you are going to have the dice to get 4 as a total.
Is the total like y or is it not?
No.
It's not y.
Y
It's
is
not,
part
it's
of
two
the,
added together.
yeah, add together.
Okay.
One fair, one from Y. This is not difficult. Actually, that's the only way. That's the only one way.
P31 is it? Oh. Oh.
Oh, why? Why not 1, 3 or 3, 1?
I cannot 31.
Yeah.
Because of this.
Oh. Oh.
Oh.
Yeah, you see the question, if the question never have the checkpoint, die already. Everyone dies. A lot of people die because they won't think about, what happened to the 1 and so on. Maybe you'll realize. When will you realize? You will realize when you start to do this. Then you find, a bit, the 1 a bit suspicious just now. That type of thing. Then you may realize. Can? Yeah, so be careful of this sort of question where there's some special situation. You need to be careful. Okay, so 2 2 2 2 means from the fair die is 1/6 from the fair. So I will make annotation like this, fair. Then the other one is 2 2 means this one. Then I will put in the expression 1/6 2 minus 1. This is the bias.
Then you times 2.
You need 2 times 2?
Yeah, cause it could be, oh.
No need. It's 2 2 is the same outcome. So there's no way for you to distinguish like 1 3 3 1. There's no way. If they are the same outcomes, then even though different dice, you cannot distinguish one. Yeah.
Is it only the same outcome because y is 2?
Yeah. Because y equal to 2,
okay.
the original die also 2. So 2 same outcomes, no need to times 2. I think when you do questions like that, you need to like not only just get the answer, but you also have to think about this sort of situation you are in. Then you try to remember this sort of situation, like, oh, next time when you do a problem, if they have the same outcome, that means I no need to do ordering. When I have different outcomes, then I need to do ordering. Then when you have this sort of thing more conscious to yourself, then you find that next time you'll become a more careful problem solver. You won't easily trapped by something. You get me? Can? Okay, so let's look at what other outcomes we can get besides x equal to 1. What other outcomes? Let's say $2, x equal to 2. So what outcomes can we get from there? Oh.
1, 2.
No, you see your 1 again wrong. You cannot have 1.
I thought it goes to 3. Oh, right. 3. Oh. Is it not possible?
Is it not possible?
There's no 0, right?
No.
It's just 1 2 2 1.
If it's 1 2 2 1, then what will happen to the Amy will pay 15
Oh.
cents. So how can the
Can
total
it
be
be
3?
Oh. 3 and otherwise?
Think a bit more. You see, what 3 or otherwise?
Because there's an option for otherwise.